Okay, this is the last video for this section, and we're going to look at a couple of different kinds of problems that we can do using trig functions. So this first problem says if sine t is 3 over 10 and t is in quadrant 2, find cosine of t. Okay, so here's what we'll do. First up, sine of t is, in terms of the size of the triangle, its sine is opposite over hypotenuse. And we're given here that this is 3 over 10. All right, so I've got to draw this. And notice it says we're in quadrant 2. So I'm going to draw my triangle into quadrant 2. Now this is t, but what we're going to use really for this is t ref, the reference angle. Or we're going to use the reference angle here in terms of like looking at the opposite and adjacent sides and such. So using that angle, the opposite side is going to be 3, and the hypotenuse is 10. So we've got to figure out what this other side is here. I'm just going to call it b. Now, we can use the Pythagorean theorem to come up with that. We know that b squared plus 3 squared equals 10 squared. And so b squared is, well, it's going to be 100 minus 9, so b squared is 91. So just solving that, we get b is plus or minus square root of 91. 91 can't be, it factors into 7 times 13, so we can't reduce the square root. But we're looking at this square root of 91. We're really looking at the coordinates of this point up here, and its x-coordinate is negative. So our b here, we're going to choose the negative root 91. So now we're supposed to find cosine of t. Cosine of t is adjacent over hypotenuse. The adjacent side here is minus root 91. Hypotenuse is 10. So this is our answer. Now, that's the best way to do this type of problem. There is kind of a cheap way you can do it also, though. I'm going to show you that too. The other thing you could do is say, well, sine squared plus cosine squared is 10. I'm going to do this over here in purple. Sine squared t plus cosine squared t equals 1. I said 10 a moment ago. I don't know why I said 10. Let me. Okay, what did they tell us? Sine t is 3 over 10. All right, so you get cosine squared t equals 1 minus 3 over 10 squared. So let's see, what is that? It's 1 minus 9 over 100. So that gives you 91 over 100. So if you take the square root of both sides of this, you get cosine t is either plus or minus root 91 over 100. Now there are two things left to do here. You can rewrite that as root 91 over 100. And then you've got to figure out, is cosine positive or negative? Well, let's see, what did they tell us? We were in quadrant 2. And if we're in quadrant 2, cosine is negative. So we choose the negative one. And that's our answer there. That bottom should be over 10 instead of over 100. I take the square root of 100 on the bottom. So that's two different ways you could do this problem, and both of them are fine. Let's do this next one. I want to do this one the same way. Do it drawing it out in the quadrant and then also just doing it the cheap way. All right, so tan theta is 5. All right, so tan theta is 5, and tan is opposite over adjacent. And we're in quadrant 3. So let's see, quadrant 3, we're going to be down here. So the opposite side, this is my reference angle. The opposite side is going to be 5. The adjacent side is going to be 1. And so the other side, by the Pythagorean theorem, you get c squared is 5 squared plus 1 squared. So this is going to be the square root of 26. And technically, this should be negative and this should be negative because we're in the third quadrant. So we're going here, we're going backward, and then we're going down. So both of those are negative. So we're supposed to find cosine of theta. Cosine of theta here is going to be adjacent over hypotenuse. So the adjacent side from here is -1. Hypotenuse is root 26. And it's fine with me if you leave it like that. The book would probably rationalize it to get negative root 26 over 26. Okay, that's doing it by drawing it out. That's sort of the proper way to do it. I'm going to do it the cheap way down here. Let's see. Tan squared is 5. Actually, since this one involves tangent, I'm not going to do this one the cheap way because it would involve using some identities that we haven't learned yet. So let's just leave this problem here. Okay, last problem. If sine is positive and cosine is negative, which quadrant are we in? All right, so let's just eliminate or keep quadrants. If sine is positive, that means we have to be either in this quadrant or in this quadrant. Neither one of these will work. And if cosine is negative, well, let's see. If cosine is negative, this one won't work because cosine's positive here. This one will work because cosine's negative here. So we're in quadrant 2. All right. I said this was the last example, but I want to do one more. I want to do one more the cheap way because it's fun. Let's say they tell you that sine of theta is, let's see, I want it to be different than this one up top. That one gave us sine. Let's do one where they give us cosine. They, like it's not me making the problem up. Let's say they tell you cosine of theta is 2/7, and theta is in quadrant 4. Find sine theta. All right, if we do this cheaply, we know that sine squared theta plus cosine squared theta is 1. So let's see, 2/7. Wait, 2/7 is cosine. All right, so this gives me sine squared theta is 1 minus 2/7 squared. So 1 minus 4 over 49. So that would be 45 over 49. So sine theta, if you take the square root of the top and bottom of that, you get plus or minus root 45 over root 49, which is 7. The square root of 45, let's see, 45, you could break that into 9 times 5, so you get 3 root 5. And then you just have to figure out, is it positive or negative? Well, we're in quadrant 4. Quadrant 4, cosine's positive there. We're trying to find sine. Sine's negative. So sine of theta is going to be the negative 3 root 5 over 7. All right, that ends this section.